Math 3, Unit 5, Section D. Today we're talking about adding and subtracting rational expressions. So basically one thing is with common denominator, I gave you the answer. What do you need in order to add fractions?
Common denominator.
You guys are amazing. So to start, we're just going to practice getting some common denominators. We're not actually going to solve these problems, but we just want to get them to have what would be the like denominator. So looking at 3, 2, and 4, what would you say would be your common denominator for that?
12.
So how did you get 12? Like, what is your thought process? That's the lowest number that they all go into. Does anybody have any other process that they use? Okay, so oftentimes, like what I do is I kind of start with like my biggest number that I have there, which is 4, and they can't all go into 4. So then I go to 8, and 3 can't go into 8, so that's not going to work. And then I go up by the next one, which is 12, and then 3 goes into 12, and 2 goes into 12. And so there's lots of ways to kind of think through it. But you know that it has to be at least as big as your largest number. So that's one thing to always think about. So here, if we're going in alphabetical order, what letter would be like my common denominator to start with? C. And then what else? What X? How many X's will I need? Just one. And then Y to the third, Z squared. Okay, so that would end up being my common denominator. So again, remember that, so see here how we have a y and here how we have y to the third. Because this denominator has y to the third, we have to have y to the third. So whatever the largest exponent is, you need that many. Is that okay with everybody? What would be my common denominator on C?
M squared minus 5x minus 14.
Or we could just write it as m plus 2, m minus 7. That would work. But yes, you also would need to know how to multiply it back out sometimes, depending on what the answer choices are. What would I have to do on D in order to figure out the common denominator? Factor them. Very good. Okay, so what would factor here? The x squared plus 2x plus 1. X plus 1 and x plus 1. Good. That could also be written as x plus 1 squared. Good. Okay, on this one, what does it factor to be? What would I do? Good. A GC of a 3x, and I'm left with x plus 1. So what would be the common denominator here? How many x plus 1s would I need? 2 of them, right? Because this denominator has 2, we need to have at least 2 x plus 1s. But then that takes care of this one, right? And then we also need a, so it'd be 3x, x plus 1 squared. Okay, so any questions on finding common denominators, like how you do that? Okay, so we're going to start with just adding fractions or that have common denominators already. So once you already have the common denominator, what do you end up doing from that point? Yep, you just add the tops, but the bottoms or the denominators stay the same. So 3a plus 3a is 6a, and then this will be over 3a minus 4. At this point, if you could factor and simplify, you would. But we can't, so that's my answer. Okay, go ahead and do F on your own and see what you can do. Okay, so you should have already had the common denominator, right? So my denominator is 2c plus 7. And then we can add together 5 and c, which makes 6c minus 28. Now, can anything be factored or anything? Yeah, I would go ahead and just to check, we could take out a 6, and that would be c minus, oh wait, that's not right. Not 6, what could I take out? 2, and I'm left with 3c minus 14, and this is over 2c plus 7, so can anything end up canceling out?
The 2's right.
No.
Oh no, it's a 2C.
We can't cancel out the 2 here because that 2 is connected to the c plus 7, right? So nothing can reduce. You would just leave your answer like that.
Wait, okay, I did it like it was like the original one, and I put a 7 out of maybe 28.
No, because remember, anything that's connected with a minus or plus sign is connected like glue. So the only way that you can cancel or reduce anything means they have to be exactly the same. Okay? All right, G. Denominators are the same. So we would end up writing this as n plus 2 over n squared plus 4n plus 4. Is n squared plus 4n plus 4, is that factorable?
Yes.
What does it factor to be?
It's 2 and plus
Good. N plus 2 times n plus 2. And so what ends up happening?
2. It cancels out.
Good. One of them can cancel, and so my answer is 1 over n plus 2. Any questions so far? Okay, so subtracting, again, we're just looking at subtracting with like denominators first. What you need to be careful of is that this minus sign needs to either be distributed to everything on the top or everything on the bottom. If you have like denominators, it makes a lot more sense to just take that minus sign and bring it to the top. Otherwise, you're going to make it so that you don't have like denominators, right? And so what I always do is take this minus sign, distribute it to everything on the top, and then that ends up changing that minus now to a plus once you distribute it. So that means for H, what does that simplify to be? Good, negative 5 over z plus 3. There's nothing I can factor. That is my answer. Okay, so the same thing on I. We have to take this minus sign and distribute it to everything there on the top. I don't want to do it to the bottom because I want to keep those as like denominators. So when I distribute this minus, this becomes a minus, and this one also becomes a minus. Once I distribute, I can change that minus sign to a plus. So now we have 9n and negative 3n, which is 6n, and negative 3 and negative 5 is, and that is over 10n minus 4. Is there anything that we can factor? Good, I can take out a 2, and I'm left with, good, and then the next one I can also take out a 2, and I'm left with 5n. Good. So since these 2's don't have anything adding or subtracting with them, I can reduce them, right? So these can cancel out. But could I cancel out or reduce these 4 and 2's? No, because they're connected with the 3n and the negative sign there. So my final answer is 3n minus 4 over 5n minus 2. Okay, go ahead and give J a try on your own. When you get the answer, raise your hand and I'll come and check it. Okay, it looks like most of you got it. The important thing is that when you see the minus sign here, you need to distribute it. So this becomes a minus and this one becomes a plus because two negatives make a positive. And that turns to a plus. 7q minus 6q is a 1q or q. And negative 3 plus 5 makes a positive 2. My denominator is q squared minus 4. Is q squared minus 4 factorable? Yeah, it is a difference of squares. So we get q minus 2 and q plus 2. And on top I have q plus 2. And so my q plus 2's cancel. So answer is 1 over q minus 2. Okay, any questions? All right, so now we're going to get to the fun stuff where we do not have like denominators. Okay. So, K, what do you notice anything about K? Good. First of all, the denominators aren't the same. Do you notice anything else about the denominators? They are opposites. What do we do with opposites? We take out a negative. Very good. So if I take out a negative here, then this becomes a negative and this becomes a positive. So if I rewrite this, I still have 3 over x minus 2, and then I have minus 2 over x minus 2. So when you take out the negative, it just kind of goes in front of that fraction. Okay? So what do I want to end up doing with that minus sign there? And how do I do that? Distribute it to the top now, right? So this will become a minus, and then I can change that to a plus.
It was a plus at the beginning, though.
It was. But then when I took out the negative to change these signs, it becomes a minus. And so then I take that minus and distribute it to the top. So my answer ends up being perfect, 1 over x minus 2. Questions before we move on there? Are we okay with that? All right. L. What would be my common denominator? 15x to the 8th, right? Because we have the 5 and the 3, so 15, and then we have to have the largest exponent, right? Serena, are you getting this? Okay, so what I normally do is I write two fractions, and they're both going to end up having 15x to the 8th in the denominator. Then I go to the first one, and I'm like, okay, what would I multiply 5x to the 8th by in order to make it 15x to the 8th? 3. So whatever I needed to multiply the bottom by, I also have to multiply the top by that number. So that means 6 times 3 makes 18. And so what I've actually done is I really have multiplied both the top and the bottom by 3 in order to make that fraction. Okay? What would I need to multiply this one by? 5x squared. So since I've already multiplied the bottom by that, because I already have the answer there, I just need to worry about now multiplying the top by that same number. And so I end up getting 20x squared there. Do we have questions on that part? Are we good with that? Yeah? Okay, so now we just add. Normally we always put like our x's first, so I'm going to write this as 20x squared plus 18 over 15x to the 8th. Is there anything I can factor or reduce? Could I factor anything out of the top?
Oh, yeah.
I could take out a 2, and we get 10x squared plus 9 over 15x to the 8th. But it doesn't help me do anything So we do realize that either one of these answers is correct. Okay? Any questions? Okay. What would be my common denominator here? Very good. So I'm going to write two fractions adding together, and both of them will have m plus 2 and m minus 7. I'm going to leave them in factored form. Why? So we might end up canceling them out later. Exactly. Okay, so what is the first fraction missing? So that means I have to multiply at 9 times m minus 7. And so you would go ahead and distribute the 9 through there. So 9 times m is 9m, and 9 times negative 7 is negative 63. Okay, what am I missing on the second fraction? Good, so we're going to go 8 times m plus 2. We're going to distribute the 8 through there, and so I get what? 8m plus 16. Okay, questions before I move any further on this one?
So you got the negative 63 because it's pretty much distributed.
I got the negative what? 63? Because I'm multiplying this 9 times the m minus 7.
Oh, okay.
And so you know how the bottom I already multiplied it by the m minus 7 because it's already here. So I have to multiply the top by it. And because we want to add them together, we want to get the like terms. And so it's easier if you go ahead and distribute and put it on top rather than doing another step. Okay, so now we can combine like terms. So 9m plus 8m makes 17m, good. Negative 63 and 16, good. And this is over m plus 2 and m minus 7. Is the top factorable at all? No. So that's my final answer. Or what could be another answer that I could see? They could end up multiplying that out, right? And so that would be what?
M squared minus 4.
M squared minus 5m
Oh.
minus 14. Okay, remember that these two numbers give you your middle number, and then those multiplied give you your end. All right, questions there?
No, either one of those is right.
Right.
Okay.
So this one or this one, sorry. I mean to put both of them together. Okay. Moving on. N. Okay, first of all, 11 right there doesn't have a denominator. So that means it has a denominator of 1. Okay, so what would end up being my common denominator for this problem? Good. 3c minus 1. So I'm going to make my two fractions, both of them having 3c minus 1. Did I change anything on the first fraction? No. So we're just going to keep that as a c. On the second one, what did I have to multiply 1 by to get 3c minus 1? 3c minus 1. So that means we have to multiply 11 times, bless you, 3c minus 1. Good. 33c minus 11. Now, what do I need to do next?
Oh.
Good. Change those signs. So anytime we have a minus here, we need to distribute it to the top. So this is a minus and this is a plus, and we change that to a plus. C and negative 33c makes what? Good. And then we just have plus 11 over 3c minus 1. And can we factor or simplify that one at all? No. Okay. Oh. Why don't you guys try this one on your own?
I thought you said, oh, we should make a mistake.
No. Oh, we're now moving on to O. Okay.
Oh, it's called
Example O. Sorry. So remember that when you're choosing your common denominator, don't multiply things out for these. So you keep them in factored form. So what would be the common denominator for example O?
A plus 3.
Good. So when you write your two fractions, and then I'm going to be quiet again, you should write this as a plus 3 and a plus 5 under both of these. And it's best to keep them this way because once we end up simplifying, we'd want it to be factored anyways to see if anything could cancel. Okay, so on the first fraction, what is it missing?
A plus 5.
Good. A plus 5. And so that means that I'm multiplying a times a plus 5. Oops. And so we get a squared plus 5a. The second fraction, what is it missing? So that means we're going to get 4a plus 12. What's the next thing I need to do on this problem?
Distribute the negative.
Very good. Distribute this negative. So this becomes a negative, this one becomes a negative, and that changes to a positive. So when we combine our like terms, I have a squared, and then 5a and negative 4a makes positive 1a, and then minus 12. And then this is over a plus 3, a plus 5. Now, can this be factored?
Yes.
Okay, and so what multiplies to be negative 12 and adds to be 1?
Positive 4, negative 3.
Good. A plus 4 and a minus 3. And that's over a plus 3, a plus 5. Nothing cancels that.
You did a lot less work than I did.
Okay? So that's my answer. But it could also be in this form, and it could also have this multiplied out too, right? Okay. All right, do we have questions on that one? Okay, example P. We'll just go ahead and do this one together. What would be my common denominator?
10t squared.
Very good. So I'm going to write two fractions with 10t squared. On the first one, it doesn't need anything, right? It's already 10t squared, so we keep the top the same. The second one, what is it missing?
5t.
5t. So we have to multiply the top by 5t. So 4 times 5t is
22.
20t. And then next step, I would do what?
Distribute the negative.
Good. So this becomes a minus, this becomes a plus. Okay, so when I write this out, it's up to you. We can write this as negative 20t plus 5, or you can write 5 minus 20t if you want to. And this is over 10t squared. Can I factor or do anything? Yes. What can I factor out? A 5. So when I factor out a 5, I get negative 4t plus 1 over 10t squared. Can I reduce anything?
Yes.
The 5 and the 10. The 10's not connected with any pluses or minuses, right? And the 5's not connected with any plus or minuses. So 5 can reduce with our 10 and make that a 2. And so we end up on top, negative 4t plus 1 over 2t squared.
How come you could divide the 5 and the 10? I thought the 10 was connected to the t.
This is 10t squared, right? There's no pluses or minuses there. And so you can reduce the 5 and the 10. It's only when there's plus or minuses that they have to be exactly the same.
Oh, okay.
Okay. All right, any other questions on this one? Oh, good.